Back again at the beach. Review number 2. Jax, it's pretty sunny out here. Can you get my sunscreen for me, please?
Nah, I'm good.
Jackson, please. I'm pretty fair-skinned.
No, you have to suffer out here for these reviews.
Jiminy Christmas. All right, here we go. Exam 2 study guide. Let's see how this goes. So, relative humidity problems. You did some of those in the exercise. Maybe on here, all you got to say is relative humidity equals what is actually in the air compared to the max amount of water vapor the air can hold, and it's always expressed in a percentage. You did orographic uplift problems also. So maybe you could just draw a little diagram, something like that, right? Where air hits the mountains and it's forced to rise, and just first write down it cools off at the DALR, dry adiabatic lapse rate. Condensation level, put that in there. Then put wet adiabatic lapse rate, and then show the air descending down the leeward side at the DALR, dry adiabatic lapse rate. Just a little diagram on that's enough for me. The location of all the wind and pressure belts. You have that, so you could draw a little thing if you want for me, and put the pressure belts on one side of the globe and the wind belts on the other. So what did we talk about? Let's see, we did pressure belts from 5 north to 5 south was the equatorial low, 25 to 35 north and south was the subtropical high, 60 to 65 north and south was the subpolar low, 80 to 90 north and pole, 80 to 90 north and south poles, right, would be the polar high. And then the winds, let's see, we did 5 north to 5 south, the doldrums, 5 to 25 north and south would be the trade winds. We went 25 to 35 north and south, the horse latitudes, 35 to 60 north and south, the prevailing westerlies, and what we go about 65 to 80 north and south would be the polar easterly. So draw a little something for me. Measures of standard atmospheric pressure at sea level. 29.92 inches of mercury, or 76 centimeters of mercury, or 14.7 pounds per square inch, or 1013.2 on the millibar scale. Does air pressure increase or decrease with increased elevation? So you want to say that air pressure decreases as you go up. There's less air on top of you. Air pressure is the weight of the air. The Coriolis in this unit results in winds being deflected to the right in the northern hemisphere, to the left in the southern hemisphere. Which local winds follow a daily or a seasonal patterns? So the ones that are kind of daily, that are in your book and they talk about, would be land breeze, sea breeze. Like where I'm sitting in the morning, sometimes the winds come off of the land. That's the land breeze. But the afternoon, right now, the winds are coming off of the ocean. You have a sea breeze. A mountain breeze, valley breeze. Where I lived in Three Rivers. In the morning, early when it was cold, the air came down from the mountain. It's the mountain breeze. In the afternoon, when the air warmed up in the Central Valley, it would go uphill. That would be the valley breeze. The seasonal one that you want to talk about would be a monsoon. A monsoon is a seasonal reversal of prevailing winds. Prevailing winds are winds that come from the same direction the majority of the time. Where I'm sitting right here on my deck in Morro Bay, the winds come off of the ocean most of the time from the west. Cyclones and anticyclones. So a cyclone's a low. In a cyclone, the air converges at the surface and rises. Motion of the air is counterclockwise in the northern hemisphere, clockwise in the southern hemisphere due to the Coriolis effect. Anticyclones are high pressure system. The air is subsiding, diverging at the surface. The motion of the air is clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. Let's see here. Cumulus clouds. They're the poofy ones, the puffy ones. I have some right above my house right now. The ones where you see animals in and they take beautiful shapes. Stratus clouds are what happen here at the beach early in the morning. They're layered or blanket type clouds. Cirrus clouds are the very high, thin ones composed of ice crystals. Do isobars increase or decrease in value towards the center of an anticyclone? You want to say that they get higher as you move towards the center of an anticyclone, bigger numbers. Would precipitation be higher on the windward or the leeward slopes of a mountain range? Like the diagram that you drew for orographic uplift, precipitation is higher on the windward side. The 3 ways to make the air rise, expand, and cool to form clouds and precipitation would be orographic uplift, convectional uplift, and convergent uplift. Is fog a form of condensation or precipitation? So it's a form of condensation. They're little particles in the air that don't, by definition, don't hit the ground. If they're heavy enough to hit the ground, then it would be rain, be precipitation. A squall line is a line of thunderstorms in advance of a cold front. When I think of squall lines, I think of Kansas in May. I think of a line of cumulonimbus clouds coming at me. I think of tornadoes. So a line of thunderstorms in advance of a cold front. A hurricane by wind speed. Those will be winds greater than 74 miles per hour. Mid-latitude cyclones, the kind of storms we get in California in the wintertime, they tend to move across North America from west to east. They tend to come from the Gulf of Alaska, be blown by the westerlies into the United States and Canada. An occluded front occurs when an aggressive cold air mass completely overtakes a warm air mass and pushes all that warm air up above. Saturation means that the air is holding all the moisture that it possibly can. 100% relative humidity if the air is saturated. The dew point is the temperature at which the air is fully saturated. Westerly winds are caused by a pressure gradient between the subtropical high, remember your diagram that you drew, subtropical high and the subpolar low. What time of the day would you expect to find the highest relative humidity? That would be early in the morning. Cold air holds less moisture, right? And relative humidity is a ratio of what's in the air compared to what it can hold. In the morning it can't hold a lot. That's the denominator of the equation. So relative humidity is higher in the morning, lower in the afternoon as the air warms up. Can jet streams, those high altitude winds, provide for heat exchange in the atmosphere? Yes, they can. They go in these big waves and bring maybe cold air south and warm air back to the north. Can lightning occur within the same cloud? Yes. It can jump from cloud to cloud and cloud to ground also. A steep pressure gradient means isobars are close together. It indicates strong winds. Is a radiation fog likely to form during an inversion? Yes. A radiation fog is what happens in the Central Valley. Right? It's called a Thule fog also. It means the air is colder near the surface, cooled below that dew point temperature, so condensation occurs. Right? So usually, right, you would get colder as it goes up. There's an inversion, right? It's warmer as you go up during an inversion. So yeah, radiation fog is likely to form during an inversion. All right, second page. The closer the dew point temperature is to the actual temperature, the higher or the lower the relative humidity. Okay, let me think about that. So that would mean the higher the relative humidity. Isobars connect points of equal average air pressure. What determines the capacity of the air to hold moisture? That's temperature. The warmer the air, the more water vapor that it can actually hold. Do tropical cyclones, hurricanes, typhoons, right, form out of a single air mass? Yes, it's one big convective cell, one big blob of warm, moist air. Understand the characteristics of warm fronts and cold fronts. A warm front occurs when warm air is the aggressor. It actively moves upon a cold air mass. Picture big chunks of air many miles across. The warm air is lighter. It can't push the cold air out of the way, so it slides up and over. Generally, we associate that with stratiform clouds or nimbostratus if it's producing rain or snow. A cold front occurs when an aggressive cold air mass, what it does is it pushes against the warm air, pushes it up pretty steeply. You tend to have more cumulus form clouds or cumulonimbus clouds, maybe heavier precipitation. Forget the matching section on the mid-latitude cyclone. Okay,